So hypothesis testing for population proportion. So this is a process that you'll be following. So if you kind of follow along what I'm doing, you should be okay. You should be able to do hypothesis testing. I'll give you more details about different terms that I'm using, okay? And don't worry about it. If you have any questions, just let me know. So Roots, a very popular TV show in the 1980s that depicted the lives of African Americans in the US. You want to know whether the majority of the people nowadays have heard of this TV show. You surveyed 350 randomly selected people, and 190 said that they have heard of or seen the show. Based on this data, would you reject the null hypothesis H naught P is equal to 0.5 at significance level 0.05? So you kind of want to know whether more than 50% or less than 50% of the people know about this show or heard of this show, okay? And you want to test that. So they give you your null hypothesis. Now, right away, I'm using a term that you haven't heard before. That's one of the questions in the midterm that got injected into by mistake. Null hypothesis is the statement that's given to you, that's assumed, okay? That's the default value. Null hypothesis is the assumed value or given value. So we are kind of assuming that about 50% of the people know about this show. So your null hypothesis is stating that P is equal to 0.5 or 50%. So that's the null hypothesis. Now, how many people you surveyed? You surveyed N is equal to 350 and P, it's not P, X is equal to the number of people that said, okay, we heard of that show. All right. So now to do a hypothesis testing, to test this claim that about 50% of the people know about this show, you kind of have to go through a sequence of steps. Number one, the requirement or normality condition. That means you want to make sure that the distribution of the sample proportions is bell-shaped. The way you do it is by ensuring that NP is greater than or equal to 10 and NQ is greater than or equal to 10, where N is the sample size, right? In our case, 350, and P is the proportion, which is 0.5. So 350 times 0.5 is 150, right? Which is obviously greater than or equal to 10. Similarly, NQ, Q is 1 minus P, and Q is equal to N times 1 minus P is equal to N is 350 times 1 minus 0.5. That's going to be 150. Obviously, that is also greater than or equal to 10. So that satisfies the normality condition or bell-shape. Step number 2, you find what is the null hypothesis, and then you find the alternative hypothesis. What is null hypothesis? Null hypothesis is the given statement, de facto statement, or given or assumed condition. In this case, the assumption is that about half the people know about this show, or P is equal to 0.5. Your alternative hypothesis, by the way, is the complement of null hypothesis, always. Alternative hypothesis is the complement of the null hypothesis, which means the complement of P is equal to 0.5. The complement of it is P is not equal to 0.5. So remember, null and alternative hypothesis, they are always complements of each other. Now, one more thing, null hypothesis will always include the equality part. Null hypothesis always includes the equality part, okay? Alternative, on the other hand, never includes the equality part. Step number 3, you have to find something called test statistic. Is test statistic, not statistics, is Z star is equal to P hat minus P divided by square root of N, sorry, not N, square root of P times Q, which is 1 minus P, divided by the sample size N. Now, P hat is something you kind of need to find. P hat, remember, is X over N, which is going to give you P hat is equal to X was 190 over 350. So 190 divided by 350, 190 divided by 350 is roughly about 0.54. Your P hat is 0.54, okay? So I'm just gonna plug in these values here. Z star is equal to 0.54, P hat minus P is 0.5, P is 0.5, 0.5, all of it divided by the square root of P, which is 0.5 times 1 minus 0.5, all of it divided by the sample size of 350. If you simplify this number, you get Z star is equal to, so let's say, what do we get? 0.54 minus 0.5 is 0.04, then divided by it gives me 1.496, or 1.5. So Z star is 1.5. The test statistic value is 1.5. And this is a value, by the way, you're gonna be using. This is the value that's gonna kind of determine whether the null hypothesis H sub 0 is rejected or not, also in combination with the critical regions. So now remember, it's a 5% significance level. So that's one piece of information you need. So we are gonna do the bell-shaped curve with a mean of 0 and a standard deviation of 1. Your alpha is 0.05. That's the 5% significance level. Now, look, you are testing P is not equal to, well, you're testing whether P is equal to 0.5, or equivalently, whether P is not equal to 0.5, right? So P is not equal to 0.5, meaning it could be greater than 0.5 or it could be less than 0.5. So you have to consider both the tails. For greater than is right tail, for less than is the left tail. And alpha is 0.05, so it has to be distributed to two tails. That's going to give you 0.025, 0.025 to the right and 0.025 to the left. And this point and this point, if you look it up from your table, this is going to be negative 1.96 and this is going to be positive 1.96. So anything from this point onwards, okay, anything from this point onwards to the left is going to be your one critical region. Anything from this point onwards to the right is going to be your another critical region. So you have two tails, so two critical regions, but we write them together. So first critical region starts at negative infinity. It goes to negative 1.96, which is this point. You unite it or union it with the other interval, which is 1.96 to positive infinity. By the way, this is step number 4, critical regions. These regions in combination with Z star value will determine whether you reject the null hypothesis or not. Now 1.5, does this value, Z star value of 1.5, does it fall in either this interval or this interval? What do you think?
I'm going to say no.
Yeah, of course not, right? So 1.96 is right here, right? 1.96 right here. 1.5 is probably somewhere here. So it does not fall in the critical region, either of them. So if it does not fall in the critical region, your conclusion would be, if it does not, remember, if it does not fall in the critical region, your conclusion would be that do not reject null hypothesis H sub 0 that P is equal to 0.5 or 50%. You do not reject the null hypothesis that proportion is 50%. So you don't have enough statistically significant evidence to justify that you will conclude that proportion or percentage of people that know about this show is anything different than 50%. And what significance level is 5% significance level. Now, these are the steps that you will go through, okay? These are the steps that you will go through when you are working on hypothesis testing. Kind of similar to confidence interval, all right? And if you understand one or two problems, you can do pretty much everything. And what I'll be doing rest of the class today and Wednesday and probably part of Monday, you should be good, because it's the same process. We're going to do it again and again and again. You just have to use different formulas. That's about it. And this process of going through the 5 steps, first one being normality condition, second one null and alternative hypothesis, third one test statistic, fourth one the critical region, and the fifth one conclusion. All of these things are pretty much the same. You just change the numbers and do repeat the process, and you'll get hypothesis testing done. Okay? Any question about the process?
Not for me yet.
Okay. What I'm going to do, I'm going to leave it on the screen. I want you to access the class notes and do the next problem. Try to do this problem, cyberbullying problem. This one, let's show you quickly. So this second problem, cyberbullying is a major issue in today's social media. The slide number 163. So please work on that. Download the new slides from Google Drive. I have uploaded it there. Then go to slide number 163 and work on this problem, everybody. Okay, I'll take the screen back and then bring everything back. So I'm leaving it here for your reference so that you have an easier time to work on the problem. So I'll give you a few minutes to work on it, and then I'll answer any of your questions if you have any, and then I will do the problem on the board. But I want you to try it. Please take a piece of paper, try the problem, and try to do the exact same process for the new problem. Then you'll really get a feel for it and you'll understand. All right, good luck. So let's go ahead and do the problem. Any question before I get going? Anybody has anything that you'd like to ask? Okay, Cyberbullying is a major issue in today's social media networks such as Facebook, Twitter, Instagram, Snapchat, etc. You are curious about the true population proportion of social media users that were cyberbullied. So you decided to take a survey of 300 people who use social media and asked them whether they have ever been cyberbullied. 80 responded yes. At 10% confidence level, test your claim that less than a third of the social media users experienced bullying. So you're trying to figure out that less than a third. So this, I just realized that for the other section, I did not read the wording clearly. So you're trying to find out whether this percentage of people or proportion of people who have been bullied on the social media is less than 30. So you're less than a third. So you're trying to figure out whether P is less than a third or 0.33. Simply speaking, this P is less than 0.33. So that's going to be your alternative hypothesis because this does not have equality in it. So just to give you a heads up, this is going to be your alternative hypothesis. And your null hypothesis is going to be complement of it, which is H sub 0 is going to be P is greater than or equal to 0.33. Remember, null hypothesis always includes the equality portion of it. Now, condition number 1, normality condition or bell-shaped, and P is greater than or equal to 10 or n times 1 minus P, also 1 minus P known as Q, is greater than or equal to 10. N is 300 times 0.33 P. Obviously, that is greater than or equal to 10. And similarly, 300 times 1 minus 0.33, that is also greater than or equal to 10. So normality condition is satisfied. Number 2, your null and alternative hypothesis. Your null hypothesis is that proportion is greater than or equal to 0.33. And your alternative hypothesis is that proportion is less than 0.33. So that's what you're testing. The left tail. Less than means left tail. Greater than means right tail. So if you have alternative hypothesis less than, is going to be left tail only. If your alternative hypothesis is greater than, it's going to be greater than, right tail only. If it is not equal to, if your alternative hypothesis, like the last problem, is not equal to, then you divide the significance level into two tails. So in this case, it's less than here. So we are going to do the left tail. Number 3, test statistic. Test statistic. So test statistic is what? Z star is equal to P hat minus P, all of it divided by square root of P times 1 minus P divided by the sample size N. Now P hat is X over N, right? X is how many people that said they have been cyberbullied. It's 80 divided by 300. So it's about 0.27, approximately 0.27. So P hat is 0.27. Now you plug in these values into the formula, and then into the calculator. P hat is 0.27 minus P is 0.33. Look, P is 0.33 because this includes the possibility that P is 0.33, all right? All of it divided by the square root of the P 0.33 times 1 minus 0.33 divided by the sample size, that is 300. So I'm going to do the math here. So 0.06 divided by 0.33 times 0.67 divided by 300 to the power 0.5, that is negative 2.21. So Z star is equal to negative 2.21. So remember this value. This is an important value and you will need it. That's the test statistic value. And confidence level is, by the way, significance level is 0.10. So let's go ahead and take the thing back. Now we are going to go ahead and find the standard normal distribution. That is going to be 0 and 1. And we are doing single tail because it's area to the left. It's 0.10. If you look it up in the table, I encourage you to look it up because you need to know how to find these values. It's going to be negative 1.28, negative 1.28. So your critical region is going to be everything to the left of this point. So your critical region, that's step 4. Finding the critical region is going to be everything to the left of negative 1.28. So it's going to be negative infinity to negative 1.28. Now step number 5 is the conclusion. Okay, your test statistics Z star is, by the way, negative 2.21, which should be somewhere here, right? Negative 2.21. So it does fall in the critical region. Okay, it does fall in the critical region. So your conclusion would be you reject the null hypothesis, which is H sub 0, that proportion is greater than or equal to 0.33. You reject this given assumption. Null hypothesis is what is given. One way to think about it is the criminal justice system in the US or around the world. Somebody is by default assumed to be innocent. Okay, by default assumed to be innocent until proven otherwise. So default assumption or the null hypothesis is that someone is innocent. Okay. So in this case, based on your calculation at 0.10 significance level, you reject the null hypothesis. Okay. You reject the null hypothesis that more than or equal to a third of the people have been abused, verbally abused on the social media. Any question, anybody on this? Now, again, is the exact same process like the one I did last time. As you can see, the same duplicate, the numbers change. Okay, so there is a question, how did I get 0.33? It's from the problem. The problem states that about a third. If you look it up, so let's bring the problem back. It says about a third at, so read the very last sentence in the problem. At 0.10 significance level test, you claim that less than a third of the social media users experienced cyberbullying. Okay, it's from the problem statement. Now I'm going to go ahead and ask you to do the next problem. Okay, so go ahead and I'll give you like 5 minutes or so, and I'll leave this screen on so that you can go ahead and work on this. Please take a piece of paper, write it down, draw the diagram, and try to work on it. That way you will learn better and you will know exactly what I'm talking about. So please try it, okay? And then I'll answer your questions as well as solving the problem. Okay, guys, any question, anybody? No questions? Okay, so let's go ahead and work on the problem. Here, what's going on? You are interested in finding out about the true population proportion of fellow students that plan to attend a four-year colleges or universities after finishing their first 2 years here. You asked 50 students and found that 30 plans to attend four-year institutions. At 0.05 significance level, test the assumption that true proportion of students that want to attend four-year institutions is different than 50%. Different than 50%. So it's either 50% or not 50%. So you can write down P is equal to 50% or 0.5. That's going to be your null hypothesis. And your alternative is going to be P is not equal to 0.5. All right. Now, let's go ahead and do something. That's the step-by-step. I mean, the sequence of actions that we take for doing hypothesis testing. So first one is the normality condition, which is NP should be greater than or equal to 10, which is N is 50, right? So 50 times P is 0.5. That's obviously greater than or equal to 10. Similarly, N times 1 minus P is 50 times 1 minus 0.5. That is also greater than or equal to 10. So good there. Step number 2, your null hypothesis. Remember, null always includes the equality, is P is equal to 0.5. Null is this. And the alternative is that P is not equal to 0.5. Null and alternative, they are always complements of each other. Null and alternative, they are always alternatives of each other. Now, step number 3, I mean, complement of each other. If I said opposite of each other, I meant to say complement. The third step is test statistic. Okay, test statistic, Z star is equal to P hat minus P divided by the square root of P times 1 minus P, all of it divided by the sample size N, or Z star is equal to P hat. So what is P hat? X over N. X is 30, N is 50. So 30 over 50 is 0.6. Okay. So 0.6 minus P, which is 0.5. P is 0.5. All of it divided by the square root of 0.5 P times 1 minus P, 1 minus 0.5, all of it divided by sample size 50. So if I do the math, what do I get? So 0.1 divided by 50 to the power this 1.41. So your Z star is equal to 1.41. Z star is 1.41. Now let's go ahead and do the calculation. So remember, this is not equal to, so we need to consider both tails, and significance level is 0.05. So remember that. So let's go ahead and create the bell-shaped. So alpha is equal to 0.05. We need to consider two tails because alternative is not equal to. So alpha over 2 is going to be 0.025. So 0.025, 0.025. And this point, as you know by now, is negative 1.96. And this point is 1.96. So your critical region CR is gonna be from negative infinity to negative 1.96 union 1.96 to positive infinity. Now let's go ahead and look at the conclusion, step number 5, which is the conclusion. Look, 1.41 positive, which is, of course, 0 is right here. 1.41 is probably somewhere here, 1.41. This obviously does not fall in the critical region. So if it does not fall in the critical region, you do not reject the null hypothesis. Do not reject null hypothesis. What is the null hypothesis? That proportion of students that want to transfer is 50%. You do not reject the null hypothesis that the proportion of students that want to go to four-year institutions is anything different than 50%. Okay, null hypothesis is that P is 50%. So you don't reject it. Okay, any question on this? Looks like no. Let's move on to the next topic. We have done hypothesis testing for proportion. Now we're going to do hypothesis testing for mean. Now for mean, there are two scenarios when you know sigma versus when you don't know sigma. So we're going to do the no sigma part today. So what's the problem here? So hypothesis testing. Mr. Zuckerberg, the founder of Facebook, recently announced that an average person spends about 50 minutes per day on Facebook, Instagram, and Messenger. Assume that the time spent on these social networks are normally distributed with population standard deviation 20 minutes. So that means sigma is equal to 20. Test the claim at significance level 0.05. So alpha is equal to 0.05. That the population mean is different from 50 minutes. So you will be having either mean is equal to 50 versus or mean is not equal to 50. These are the two things. So there's the first one is going to be your null hypothesis. The second one is going to be your alternative hypothesis. Remember, null and alternative hypothesis, they are complements of each other. Okay, they are complements of each other. Okay. Now, interestingly, this problem is also exactly the same as what we did last once. Only difference is that this time we are doing it for mean as opposed to proportion. So let's go ahead and do this. In this problem, it says that it's normally distributed. So normality condition is okay. So number one, bell-shaped, it's okay. But if it did not tell you whether it's bell-shaped or not, in that case, you have to make sure that n is greater than or equal to 30. Remember central limit theorem? If sample size is bigger than or equal to 30, then the sampling distribution is always going to be bell-shaped. All right. Number two, null hypothesis, which is mu is equal to 50, and your alternative hypothesis, which is mu is not equal to 50. Mu is 50 versus mu is not equal to 50. Number three, your test statistic Z star, in this case, is going to be X bar minus mu divided by sigma over square root of the sample size n. Now, all this information you have from the problem. Your mu is 50, right? Minus 50. X bar is the mean. So based on your sample of 200 people that yielded an average of 40. So X bar is 40 because you got the number 40 from a sample of 200 people. Your n is 200. Divide by sigma, which is given 20. 20 divided by square root of the sample size 200. And if you do the math, which is not very hard, by the way, it's gonna be 40 minus 50 is 10 negative, right? Then times, if you flip the bottom, it's gonna be 200 divided by 20. 10 goes into 22 times, so z star is equal to negative square root of 200 over 2 is the same as square root of 200 over 4, the whole thing under the square root. That's the same as z star is equal to negative square root of 50, which is z star is equal to negative 7.07. Okay, z star is equal to negative 7.07. Now we are going to go ahead and do the critical region. So step 4 is going to be your critical region. You draw the bell-shaped curve. Okay, your mean is 0, standard deviation is 1. So now it's not equal to, so you have to do a two-tailed test. And what is the significance level? 0.05. So your alpha is 0.005. So alpha over 2 is 0.025. So this is gonna be 0.025. And this is gonna be 0.025. So this point is going to be negative 1.96, and this point is going to be positive 1.96. So your critical region is going to be negative negative infinity to negative 1.96 union 1.96 to positive infinity. Now, step number 5 is your conclusion. Look, so let's go ahead and look at the stuff here. So your z star is negative 7.07, which is probably going to be somewhere way out here, negative 7.07, right? It's way out there. So it is in the critical region. If it is in the critical region, you'd reject the null hypothesis. So you reject the null hypothesis H naught, that mu is equal to 50 at 5% significance level, 5% significance level. And that's how you do the entire problem. So this is what the process is, and this process is exactly the same as what we did before. All right, so nothing new. Nothing out of the ordinary. If you understand one of them, you should be able to do all of them. Okay, you should be able to finish all of them. So to be consistent with my other section, I'm going to pause here for the day. Okay, because this is how much I was able to cover in my other section. So I'll just stick to this point. So please go ahead and look at the remaining problems. I have updated some of the problems on the class notes, I think. So try those, and I'll be putting in more problems. You're welcome to look at them. And on Wednesday, I'm going to finish the hypothesis testing, all of it, okay? Because once you get the hang of it, the rest becomes very routine and very standard. You just follow through the steps, and you should be able to get the conclusion or do the hypothesis testing. So we did hypothesis testing for proportion. Now we are going to do hypothesis testing for mean, for which we have two scenarios, when you know sigma versus when you don't know sigma. We just started the case where we know sigma. In that case, we use the z-scores, okay, z-scores or standard normal distribution. But if we don't know the population standard deviation, in that case, we use the t distribution or student t distribution known as, okay? So these are the two scenarios. And the process is the same as it is for z-score, the same is for t-distribution, very similar process. Once you understand one, the rest becomes easy. Any question, anybody?
Will
No.
you be sending out this recording today by any chance?
Yes, I will be
Okay.
sending today.
All right, thank you.
Any other questions, anybody? All right, thank you very much. Have a wonderful day.